Welcome to the distributed system course. In the previous session, we discussed election algorithms in distributed systems. Today, we are going to discuss the agreement protocol in distributed system. First of all, we are going to know what is agreement in a distributed system. As we all know, all the nodes in the distributed systems are working together in a cooperative cooperation to achieve a common goal. Hence, cooperation among the process is very necessary. There is some standard agreement protocols in distributed system. We will see each problem and try to find some protocols or algorithm to solve the agreement problem. The agreement protocol is used to ensure ensure that the distributed system is able to achieve the common goal even after occurrence of various failures in the distributed system. That is also we need an agreement between the processes to achieve a common goal. Then why agreement in particular distributed system? To achieve some common goal in distributed system, to deal with various faulty process which might produce wrong result and send the wrong information to other process. So to deal with the various faulty process which might produce a wrong result and send wrong information, we need the agreement. To achieve reliability in the distributed system also, we need the agreement between the processes in the distributed system. That is the need of the agreement in distributed system. Then to achieve the reliability in the system, we also use the agreement. The problem which requires the agreements are the mutual exclusion and the leader election algorithm and distributed transactions. See the mutual exclusion algorithms. There is the Lambert algorithm and Ricard Agarwala. In all the cases, all algorithms, we need some agreements between the processes. So for that we are that is one of the problem in distributed system which required agreement. And another one is the election algorithm or leader election algorithm. We already discussed the Bully and the ring algorithm to elect a coordinator in a distributed system, which also requires the agreement between the processes. Another one is the distributed transaction. That is, in distributed database, there may be a situation where data manager have to decide whether to commit or abort the transactions. We all know the transaction is a set of logical operations, that is read and write, and in the database. In the case of distributed system, it is running in different systems or a different site or different process. So to commit or abort a transactions, we need the agreement of all process that involved in the transactions. For that also we need the agreement between the process. So there are so many problems in distributed system that require this agreement. The agreement always required to achieve a common goal in the distributed system. That is, there may be mutual exclusion or election of election of coordinator, or about or make a decision whether to commit or about the transaction. When there are some type of faulty process present in the distributed system, at that time we need to make sure that the performance of the distributed system should not be affected. At that time we implement some agreement protocols so that the output of the distributed system should not be incorrect and should not be affected in the case of failure also. That is the main goal. First of all, we will discuss the system model in the system. That is, there are agreement problems or that have been suited under a system model. That is, there are n processes and in the distributed system, and at most m processes can be faulty. That is, we considering that there are totally some processors in the distributed system. Out of that, it can be some of the at most some of the them can be faulty process. That is the first model, first assumption. The processors can directly communicate with the other process by message passing. So we already seen that the message passing is the only methods in distributed system to communicate between the process, because there is no common memory and common clock. A receiver process always know the identity of the sender process of this message. We see in the previous sessions also we include some logical number, that may be network ID or process number, to identify the sender process. The communication medium is reliable. We assume that the communication medium is reliable, and the processes are prone to failure. That is, process can crash or fail, but we assume that the communication medium is reliable. First of all, based on this model, we can classify the failure of this process. The processor can fail in 3 modes. That is, first one is crash fault, then second one is omission fault, then last one is malicious fault or Byzantine fault. In the crash fault, a processor stop functioning and never resume operations. That is, it is going to crash. It cannot restart at that time. So it will stop functioning and never resume its operation. That is the case of crash fault. Come to the second fault, that is omission fault. A processor omit to send message to some processes. That is, it does not send a message. That is called omission fault. Then the most important fault in the processor is the malicious fault. That is also called Byzantine fault. A processor behaves randomly and arbitrary in this Bayesian fault. That means it does not send correct information. It can be disloyal at any time. So we don't know the particular process is sending correct information, or it is disloyal or loyal. The loyal means it is sending the correct result. Sometimes it can be a faulty system, or faulty node can be in a distributed system. So that is the case. There are we cannot trust on this faulty process. There are two. We can mainly say that there are two categories of failure that are considered. That is, one is fail stop. Fail stop means it is stop which node fails and stop operating. And the other is arbitrary node. The arbitrary node failure. Some of the arbitrary node failure are, that is failure to return a result, or the respond with an incorrect result, or respond with a deliberately misleading result, or respond with a different result to different parts of the system or different processors in the system. That comes under the Byzantine fault, or we can say that malicious fault sometimes. That is about the failures of the processors. The Byzantine fault is most dangerous, and at the same time it is very tough to dictate in our system, or we cannot correct. It is tough to dictate or correct the Byzantine fault in distributed system. Then come to the computation. We can classify the into two. That is, first one is synchronous communication or computation, then second one is the asynchronous computation or communication. In the case of the synchronous computation, the process run in a lockstep manner. That is, lockstep means a processor send a message to its earlier process and perform some computation, and send a message to other process. That is three cases. The processor receive a message to a message is sent to its earlier, then perform some computation and send a message to other process. That is, it is happening in a finite amount of time. It is happening within a finite amount of time. That is the case of this synchronous computation or communication. Every steps in the synchronous communication or computation is called a round, one round. So in the case of the synchronous communication, the message delay is finite, but in the case of asynchronous communication or computation, the message delay is infinite. Also, the computation does not proceed in a not in a lockstep manner. In asynchronous computation, processor can send, receive message and perform computation at any time and any order. That is the case of asynchronous computation. To the sake of simplicity, we are assuming synchronous model of computations are assumed in our system. In a synchronous model of computation, the omission failure can be easily detected. Omission failure or omission fault can be easily detected. So there are two mode of communication, asynchronous and synchronous. It is in the case of synchronous, it is happen in the finite memory message delay, but in the case of asynchronous computation, it is happening infinite message delay. That is about communication or computation. Then come to the messages. That is, to reach an agreement, the process need to exchange their values. That is, exchange their values by means of message. The relay received a value to other process. The two types of messages are the authenticated message and non-authenticated messages. When it comes to authenticated message, it can also we call it as a signed message. That a process cannot forge or change a received message. So the processor can verify the authenticity of the message in the case of authenticated messages, but in the case of non-authenticated message, it is not possible. Also, in the case of authenticated message, it is easier to reach on an agreement in the distributed system. But in the case of non-authenticated message, it is very difficult to achieve an agreement or common goal or a common decision in the distributed system. When we compare the non-authenticated message with the authenticated message, we can say that it is a oral message. So the processor can forge or change the received message at any time, and claim that claims to have received it from others. So there is no authenticity in the message in the case of the non-authenticated message. That is about the messages. Then come to the next, that is performance aspects. The performance of agreement protocol is generally determined by some metrics. That is, first one is time, then second one is message traffic, and the last one is storage overhead. The time is number of rounds needed to reach agreement. We already seen the what is round. That is, each steps in particular synchronous communication or computation is called a round. So the time depends on the number of rounds needed to reach an agreement. Then second performance metric is the message traffic, the number of message exchanged to reach an agreement. The last one, that is the storage overhead, the amount of information that it needs to store at a process or processors during execution of the protocol. So the amount of information needed to take a decision, that is called storage overhead. Then the number of messages transmitted or exchange between the process is called the messages. The number of rounds needed is called is taken as the performance metrics time. Then Then next is the classification of agreement problems. Mainly the agreement problems are classified into three. That is, first one is Byzantine Agreement Protocol, then consents problem, then last one is interactive consistency problem. Then first we will see what is the Byzantine Agreement protocol or problem. In the case of Byzantine Agreement problem or protocol, a single value is to be agreed upon. That is, our final goal is to get a single value among all the processes. For that, we are using we choose an arbitrary processor, and that is called a source processor. That source processor broadcasts its initial value to all other processors. So we select one of the processor from a set of processor in the system, that is called source processor. That source processor broadcasts its initial value to all other processors. Then the agreed value is initialized by an arbitrary processor, and that is the source processor, and all non-faulty processors have to agree on that value. That is the case of the Byzantine agreement protocol. So here initial values seem to by or are initialized by a single processor, that is called source processor. It broadcasts its initial value to all other processors in the system. Then after that, all other non-faulty processor have to agree on the value initialized by the source processor. That is the idea of Byzantine agreement protocol. Then when we come to the agreement protocols, that is the Byzantine agreement protocol, then the solution must meet some of the objectives. The first one is agreement. That is, all non-faulty processors agree on the same value. That is agreement. So to meet the solution, so all the solution must meet all these three the three objectives. That is, first one is agreement. So our goal is to all non-faulty processes, that is in the system may contain some of the faulty processor and non-faulty processor. We are considering only the non-faulty process in agreement. All non-faulty processor agreed on same value. Then come to the second objective, that is validity. If the source processor is non-faulty, then common agreement upon value by all non-faulty processors must be same as the initial value of the source. That is the validity of that particular solution. Then that means if a particular source processor has some value, then after the agreement, all non-faulty processors in the system must be initialized with the same value of the source processor. That is about validity. Then the third objective is the termination. Then each non-faulty processor must eventually decide on value. That is about the objective. If in the case of Byzantine agreement problem or protocol, if source is faulty, then all the non-faulty processor can agree on any common value. We select one of the processor source node, it is start to broadcast. That can be also a faulty node. So if the source is faulty, then all the non-faulty processors can agree on any common value. At the same time, value agreed upon by faulty process is irrelevant. It is not relevant, irrelevant. That is about the first protocol, that is Byzantine agreement protocol. Then come to the second agreement protocol, this is consensus problem or protocol. In this agreement protocol, every processor has its own initial value, and all non-faulty processors must agree on a single common value. That is, in the previous case, only a single node is initialized with some values. In the case of consensus problem, every process has its own initial value, and all non-faulty processors must agree on a single common value. That is the idea. Then come to the objectives. Then every process broadcasts its initial value to all other processes. That is the case. So that is in the case every process has its own initial value, and all non-faulty processes must agree on a single common value. Every processor broadcasts its initial value to all other processors. The initial value must be different from the different process. So after the execution, the protocol will provide some solution. It must contain some objectives, that is agreement, validity, and last one is termination. That is the case. So when we compare the consensus problem with the Byzantine problem, in consensus problem, every process in the system has its own initial value, and all non-faulty processor must agree on a single common value. That is the idea. For that, every processor broadcasts its initial value to all other processes. Then initial value may be different for different processes. So the protocol must meet the objective. First one is the agreement. All non-faulty processes agree on a same single value. Then come to the validity. If all non-faulty processes have the same initial value, then the agreed value by all the non-faulty processes must be that same value. That is the idea. If the initial value of a non-faulty process are different, then all the non-faulty processes can agree on any common value. There are two situations are there. In the case of the Byzantine, there is only one source node that broadcasts its value to all other processes. Then after the execution of this protocol, there is an agreement on that particular non-faulty process in the system. In this consensus problem, every process has a initial value that each and every process broadcasts its initial value to all other processes. Then after that, it will come to a common value in the distributed system. So if all the non-faulty processes have same initial value, then agreed value by all non-fault processes must be same after the execution of the protocol. If the initial value of the non-faulty processes are different, then all the non-faulty processes can agree on a common value. The value agreed upon by faulty process is irrelevant. That is about the consensus problem. Then come to the interactive consistency protocol or problem. In this case, every process has its own initial value, and all the non-faulty processes must agree on a set of common values. That is the idea. So every process broadcasts its initial value to all other processes. The initial value of the process may be different. A protocol for the interactive consistency problem should meet the conditions, that is, all non-faulty processes must agree on a same array of values. Then come to the validity. If a process I is a non-faulty and its initial value is vi, then all the non-faulty processes agree on vi as the ith element of the array. If the process j is faulty, then the non-faulty process can agree on any value for aj. That is the condition of validity. Then come to the termination. Each non-faulty process must eventually decide on the array A. Then if the jth processor is faulty, then all the non-faulty processes can agree on any common value Vj. That is the idea. If it is a faulty process, then it can agree on any common value Vj. Value agreed upon by faulty processor is irrelevant. So in the case of the interactive consistency problem, here the all non-faulty processor must agree on the same array of values. That is the case of the interactive process. Then we can compare these three protocols. In the case of Byzantine agreement protocol and interactive consistency problem, all non-faulty processor must reach an agreement. In a Byzantine and consensus problem, agreement is a single value. That is, it is going to agree on a single value. That is the first and second case. That is Byzantine and consensus problem, agreement is on a single value. In interactive consistency problem, agreement is on a set of common values. That is the difference. In the case of Byzantine and consistency and interactive consistency problem, all non-faulty processes must reach an agreement. Then that is the case of all the cases. But in the case of the Byzantine and consensus problem, agreement is on a single value. But in the case of interactive consistency problem, agreement is on set of common values. That is the idea. In Byzantine agreement problem, only one processor initializes the value, whereas in the consensus problem and interactive consistency problem, every process has its own initial value. That is a difference of these three interactive these three agreement protocols. In the case of the Byzantine and consistency problem, agreement is on a single value. In interactive consistency problem, agreement is on a set of common values, the array of values. In Byzantine agreement problem, only one processor initialized it to a initial value, whereas in the case of consistency and in interactive consistency problem, every processor has its own initial value. That is a comparison of these three agreement protocols. In the next section, we will see some of the examples of these consistency problems and in the next section.